Assalamualaikum warahmatullahi wabarakatuh to Dr. Hafiz. My name is Nur Izzati binti Maliasha. In this video, I would like to present the result that I obtained in this lab session. In this lab session, the student has been asked to design two conditions of the wind bridge oscillator. The first condition is a wind bridge oscillator without amplitude stabilization. To design a wind bridge oscillator, firstly, we need to determine the value of each component. Given the frequency, FO is equal to 3 kHz. For RC network, firstly, we assume C is equal to 10 nanofarad. By using formula FO is equal to 1 over 2 pi RC, we obtain the value for the resistor R is equal to 5.31 kilo ohm. For RC network, C is equal to 10 nanofarad and R is equal to 5.31 kilo ohm. For the feedback resistor, firstly we assume RA is equal to 1 kilo ohm. By using formula RF over RA equal to 2, we obtain RF is equal to 2 kilo ohm. So RA is equal to 1 kilo ohm, RF is equal to 2 kilo ohm. This is the wind bridge oscillator without amplitude stabilization circuit that has been constructed in multisim. This is the RC network. C1 and R4 connected in series is high pass filter, while C2 and R1 connected in parallel is the low pass filter. R3 is the RF and R2 is RA. Now we run the simulation. This is the output waveform for the wind bridge oscillator without amplitude stabilization. We can observe that the peak of the output waveform is equal to 1.144 nanovolt. The peak value is small. And we also can observe the output frequency for the oscillator is 2.95 kilohertz, which is close to the given output frequency 3 kilohertz. The second condition is a wind bridge oscillator with amplitude stabilization. We need to consider two conditions of diode. Firstly, when the diode is off, we assume R6 is equal to 2 kilo ohm. By using formula R3 over R6 greater than 2, we obtain the value for R3 is equal to 4 kilo ohm. The second condition is when the diode is on, the gain of the amplifier will slightly less than 3. By using formula 1 plus R3 parallel with R5 over R6 smaller than 3, we obtain the amplitude gain is equal to 1.4175, which is smaller than 3. This is the wind bridge oscillator with amplitude stabilization circuit. We add two diodes in the circuit to use for amplitude limiting, and we also change one resistor with a potentiometer. Then we run the simulation. This is the output waveform of wind bridge oscillator. At 20% of the potentiometer, the oscillator will start to oscillate and the output waveform will start to grow. At a certain value of the frequency, there will be a small distortion on the output waveform. We need to adjust the potentiometer to 25% to get a smooth sine wave output waveform. We can observe that the peak of the output waveform is equal to 503.677 millivolt, which is a likely increase. Then you also can observe the output frequency of the oscillator is 2.876 kilohertz. Thank you for lending me your ears. That's all for me. Thank you.